Hello and welcome to Deep Dive. What is up? Be Autograph over on YouTube chat. Nice to see you, my friend. Hope everyone's having a good day, good week, all that stuff. I will mention sorry up front here if I am a little less talkative than normal and or not talking particularly loud. I've had kind of a sore throat a bit today, so I may be not talking quite as loud or talking quite as much as usual. Also, I'll probably be drinking a whole lot of water, and I also have a coffee here. So I may end up having to also run to the restroom once or twice because I've been drinking lots of water all day because it's making my throat feel better, which it does feel better than it did this morning. So I'm happy about that. Feeling good, feeling better than I did. But with that sort of housekeeping out of the way, let's do the normal intro. So welcome, first of all. Thanks to everyone who is watching. If you are new and don't know, my name is Tim. I go by Foamy Guy on GitHub and Discord. This is the Deep Dive, which is weekly live stream where we are working on stuff related to CircuitPython. If you don't know what CircuitPython is, you can learn more about it at the main website for the project right here, circuitpython.org. This is basically a version of Python that runs on tiny computers called microcontrollers like these ones. Typically, the way it works when you choose to use CircuitPython with your microcontroller, there are lots of different ways to program these devices. CircuitPython is just one of them. But when you use CircuitPython, the way it tends to work is you plug it into your computer with a USB cable. It shows up like a thumb drive, and then you can edit a Python code file that is on that drive. And when you save it, the microcontroller, the actual computer that is in these chips on these little boards, will execute the Python code for you. And then microcontrollers, there's sort of a range of different devices. Lots of them are general, where they just have loads of what they call I/O pins along the sides. Like these ones have a lot of different I/O pins. You can hook up other electronics to these pins. Other ones are a little bit more purpose-built. You know, something like the Pi Portal is sort of a little tablet-like form factor. It's got a touch screen. A touch overlay as well as a TFT screen. It's got, I think, an accelerometer, a couple other things. Got some easy plugs on the side. But what it does not have is it does not have loads and loads of I/O pins. Lots of them are used for the onboard peripherals. So this is a bit more purpose-built. And then, something like these Picos here is a very general device. You would put this in your own project and you hook up whatever little bits and bobs you want to make it do whatever it's going to do. As always, we will say thanks to Adafruit. Adafruit is a hardware and software company based out of New York. They are the ones who make CircuitPython possible by paying myself and the rest of a team of folks who work on the project. There are some folks who work on the project full-time. There are some folks who work on the project part-time. And Adafruit makes that possible. If you would like to help support them and CircuitPython and all of the other open source software that they pay developers for, one of the easiest ways you can do to support that is by purchasing hardware from them at their website, adafruit.com. They have all sorts of microcontrollers like the ones we were talking about, including the Pi Portal. They sell Raspberry Pis, but of course that's made by the Raspberry Pi company. But there are Adafruit designed microcontrollers, such as this Feather RP2040 that I have here on the live cam. They also have all sorts of stuff that you can hook up to your microcontrollers, like these sensor breakouts that I have over here. There's also rainbow lights and buttons and all kinds of other fun stuff that you can find on the Adafruit shop, which again, if you want to help support CircuitPython and all the other open source work that Adafruit funds, you can head there. Purchase hardware from them. If you do, then thank you for doing so. So, what is up over on Discord? Y'all know Mark Gambler and David, let's see, Wanoni? I don't know how to pronounce the second bit there, but what is up to all of you? Thanks for tuning in, folks. It's nice to see all of you. So I am diving in today with register SPI stuff, which I worked on stream, I think not last week, but maybe the week before. And I'm not sure if I did it on Deep Dive or if I was over on my own stream. I'd have to go back and look at the titles to be sure. You kind of, once the show ends and I move on to my Saturday show, I don't necessarily remember what always I work on which week. But I think that I started this work on the stream a couple of weeks ago, and then last week I was working on the SPA 06003, which is down here. I was working on the I2C driver for that last week, but now I got that working. So if anyone happened to catch last week's deep dive and my stream, towards the end of my stream, I was stuck on the SPA 06. I was getting the wrong value for temperatures. And I figured that out this week. And so I've got that straightened out. The driver, the I2C driver for that is published. Everything's all good there now. And so I've been diving back into register SPI work. And this is all centered around trying to make it so that we can have drivers that are sort of like bus or transport layer agnostic. So if I open up this BMP5X driver right here, and I will note this is a development version of the driver. If anyone happens to be following along and you wanted to like use this for real, like you cannot get it in the published version, right? If you get 1.0 from CircUp or whatever, you're not going to have this. This is over here in this branch that there's a PR open for. So if anyone who's watching wants to actually see the code, that is where it's at, this PR number 3 on BMP5X repo. It's very similar to the published one. The main differences are that the classes that are imported here are different. They're now generic register bits instead of I2C bits like they were before. And then there is just a little bit here in init. We now can accept an I2C and an address just like before, but we also accept an optional SPI bus and a CS pin. If those are provided, then we will, of course, set up a SPI device. And if the I2C stuff is provided, then we'll set up the I2C device. And what I have done here is we have this new layer called the register accessors. These create sort of an interface that knows how to read and write registers over a certain bus. So we have a SPI register accessor, we have an I2C register accessor. In both cases, they get stored on the driver here as like self.register accessor. And then the bits classes, those are descriptors. And so the way they work is they have this get and set value. And when those get called, the object gets passed in, and the object will be this class. It will be an instance of BMP5X. So inside of here, when we go object.register accessor, we're actually getting this register accessor here or this register accessor here, depending on whether SPI or I2C was initialized. And then it just has a generic read register and a write register function. And so now the bits classes don't need to know anything specific about I2C or specific about SPI. They just say, read the register, give me back the data, and then I'll do what I want with it after that. So this is kind of the separation here. And so where I am jumping in specifically, first of all, I thought it would be cool to show that I do have this working. The SPI driver is now working, and I have, in fact, even set up 2 devices here. So there is a bit of a mess of wires because SPI uses a lot of wires, and I have essentially jumped the SPI bus from here over to here as well. So I essentially have 2 of these sensors both connected to the same SPI bus, and then of course different chip select pins there. And I'm reading data from both of them. This is using this whole new register accessor layer, the register bits and bit, the generic classes here. So this is what I have been working on today and yesterday, and we are coming along quite nicely. The thing where I'm going to start, though, is we're actually going to start on this other one, SPA 06. We are going to try to make that SPI capable. Because right now, that one is I2C only. I mean, technically BMP is as well. I just have that PR open, like I said before. Here we go. What is up, Paul Cutler? Good afternoon to you as well. Nice to see you, my friend. Oh, I still have unneeded import there. Okay. I just copied that in from the repo. I should have probably made sure. Let me make sure we're actually working. Oh, okay. We're actually working from current main. So the main things we need to change here are where we import this. And then we'll get into some more funky stuff here in a minute, but this part is easy. If anyone did happen to catch my stream and deep dive last week, if you did see where I was stuck on the SPA driver, if you happen to be interested in the resolution to that, the resolution turned out to be down in here where we set the temperature oversampling. It turns out that if you use the top half, the fat, there's like, you know, all these oversample values, 1 to 128. If you use anything greater than 8, so if you use the top half of these that have the most oversampling, you actually also need to set this other thing, bit shift enabled. So for temperature, if your oversampling is higher than 8, you need to use shift enable true. And same thing for pressure. If you try to set your pressure oversampling to greater than 8, then you also need to set this bit shifting thing to true. I didn't have this register when I was working on it during the last stream, and so I was getting the wrong data because it was not shifting those bits around how it was supposed to. And so that's the resolution to that. I like to try to, if I end on a mystery where it's not working, I try to remember to go back and say what happened. Not only for anyone who's watching that's curious, but even potentially for myself if I come back, you know, a couple months from now and I'm like, what was I doing on that thing? The beginning and end of my streams are invaluable for that. Go back and look at what I was doing and where I was at, what I was thinking. Okay, that was the resolution to that. We need to get to init so that we can set up the device stuff here. So right now, this is of course just I2C only, so it's just setting up the I2C device and that's it. We want to basically do the same thing we did in this one, where we're going to be accepting also SPI and CS pin all the way back here. Wait, no, is it? Init. Oh, it's right there. Okay. I'm going to go ahead and break these down. Okay. It doesn't know the types to those. Here and grab those, SPI, and then I ended up finding that issue with the bit shifting by looking at the traffic on the bus. I found the debug. Lemore showed me the debug flag in Arduino so that I could look at all the bytes that are being read and written over the bus, and I happened to notice there was like a weird extra write that was happening after the oversampling was set that my code was not doing, and so that's what led me down the road there to find that. Me every few minutes. What was I doing on that thing? Yeah, that's... Well, I've got... Certainly have an attention span that fits the generation, let's say. And I'm not quite this generation, so it's maybe better than some that are out there, but yeah, I grew up in the 90s. I grew up on relatively quick TV style stuff. So attention does blink fairly quickly sometimes. All right, so we've got these now. Do this, and yeah, I find myself like I find it super valuable to be able to come back to the beginning and the end of the streams and see what I was saying, because I kind of try to leave myself breadcrumbs We will need SPI device also, and we'll need both of these accessors as well. So let's get those. Oh, hey, there's a SPI there too. That's weird. That's a different thing. Register access. Oh. I2C. Oh, okay, so currently that's called I2C bus. I think I'm gonna change that to just I2C. Let's look at another one first, though. Let me look at an old one. I'm pretty sure these usually just are I2C instead of I2C bus. I hear that. It's cool you've got a memo workflow hack. Just watch a few minutes. Yep. Wait, what? Oh, okay. It's not showing. I was like, where's the code? There's no code. It was truncating the files randomly. Though it was really width that it was lacking. Choice, but okay. Init. Oh, right. So this one, so this is actually a bit of a change to the API layer. So in this old way, we actually had two separate classes: one driver for I2C, one driver for SPI. In the new methodology, there's one driver that does both, and inside the init is where it essentially makes a decision of which you're going to use. And it does just call it I2C. I'm going to go ahead and change that, even though this was I2C bus before. I'm going to change it to I2C only just so it matches all the other ones. Okay. So that should basically work. I don't know if this is necessary. Probably not. I'm going to leave it for now. One thing that is going to be necessary, though, is... pretty sure this thing defaults to a different mode. Oh, that's handy. This data sheet actually tells you which one's which. Look at that. The BMP data sheet, I did not actually find that specific information anywhere. It told me like the top bit was for the command, the read command or the write command, but it did not, it never spelled out that read was 1 and write was 0. So the thing I'm actually looking for, though, is... so SPI has this concept of, like, mode 1 and mode 3, which is something to do with the phase of the clock. And I will not claim to know anything more specifically than that, because I don't, but I'm pretty sure that this one is, like, opposite the other one. We actually are going to need to use mode something else. But I don't know, like, which thing... polarity. That. The base state of the clock pin. Yeah, so this defaults to 0. Mode 3. I'm pretty sure that's the thing I'm talking about. I don't know what these mean. Oh, polarity? Maybe that's polarity and phase. Do we have a phase? We do. Okay. So we need to probably set both of those to 1. That might be all we need to do if we're lucky. Polarity? Okay. Let's try that. I'm going to save this. Right now my code has got the 2 BMP sensors that I showed before with both of these hooked up here on the same bus. So I'm going to stop that for now. And I'm also going to just unplug this. I've been trying to like not necessarily be doing hot plugs just in case if I end up off by a pin or something. I don't want to be plugging ground into power or anything like that. Pick these out. One thing I have found is the BMP 580 and the 581 are both working for me on SPI. But the 585, which I have here actually connected to I2C right now through its little stemma cable there, this one is not working for me on SPI. And I don't know if I just bungled it when I soldered it somehow, or if there is some other issue with it. In, we got 3-volt out is skipped, then we got our ground, then we got our mess of I2C cable. See the skip there on the 3-volt out. Okay, that should be in. We're going to need the code to test it, which is going to be similar to this, but we are going to have to redo it a bit. This could be a sleep. Small. I think the other one sleeps for like 1 whole second. Although it is outside of this, I guess. That for now. Could probably stand to be a little slower, but better that. Okay, we'll plug this back in. One of the cool things about this, like the way this is factored out now with the register accessor layer, it's gonna make it so we can add more types as well. So I know there's a couple weirdo devices that use like a UART sort of register system. What is up over on YouTube, by the way? I think I saw this a couple of minutes ago and I forgot to mention it, but what is up, my friend Bargov? Fadula? My apologies if I got your name wrong, but thanks for tuning in. It's nice to see you, my friend. We're going to put this, we're going to change it over to be SPI. Need the CS pin. My CodePy is like getting out of control here. I have like 5 different CodePys that are just all commented out, and I'm like scrolling to paste new ones in all the time. I'm just gonna worry about one for right now. In fact, I only have one SPA device, so. Yeah, and this, so the way it's wired up, this one is on the blue wire right here is the CS pin, and it's on the feather pin 10. And then if there was one down here, it would be on pin 11. It is not currently plugged in. All right, so one thing is you have to use the named variables now for SPI, but not I2C. Is a little bit awkward, but not the end of the world, I think. Basically, what it boils down to is SPI defaults to none. I mean, I guess I2C technically defaults to none also. Just doesn't explicitly call it that. And then basically it goes and it says which one is none. Did they pass the SPI ones, or did they pass the I2C one? We should maybe, I wonder if we want handling for if they try to do both. We shouldn't, probably should raise an exception if they did. But that later. Send it, see what happens. Unexpected keyword argument signed. Oh, okay, so I should, for one thing, we need to, okay, a couple of things actually. We need to, I want to change the name, because I did originally name this assuming that we might have different classes, but that's actually no longer the case. And then it looks like I never did implement signed. It looks like basically all of these are saying signed does not exist. So we're going to need to add that to register bit and bits. Kind of surprised it's not there already. But I guess the BMP didn't have to use it, so. So bit doesn't have it, right? Bit can't be signed because it's only for a false. Did I add this? Hold on, I gotta check if I added this. I didn't mean to add this to this class if I did. Oop. I have commit that's not put. Does this actually have register? No, address. Okay. Yeah, that's not there. Okay. You know what I did is so I'm on my device, right? This is device workspace. This is in my lib folder, which is where I have been editing code. Yeah, and this is a new thing that I have added to the new way that does not exist in the old way. The old way, I2C bits class and bit as well, they assume that the register will be only a single byte, and technically actually only 7 bits for SPI at least. But the new way actually supports multi-byte addresses. It turns out, I think there's a couple weirdo I2C devices I saw reference that maybe use a 10-bit address. And then for SPI, if I understand correctly, it's not necessarily standardized. You could have an address of 1 byte or 2 bytes or 3 bytes or as many as the device wants, really. It just depends how many registers it has. And so this new refactor actually is attempting to support that multi-byte address width. We always supported multi-byte registers, of course, but this is specifically the address. And I accidentally added it here without meaning to. Long story long there. But we want to do is the signed stuff. So we should do that. And I think I'm going to put it here so that it comes after least significant bit first. That way we kind of keep the same order as this one. Okay, just totally skip this. That. We'll delete this now. This was weird. It was like storing the width of the register in the byte with index 1. But I don't, it was never like using that I could see. In fact, this code doesn't do it, but maybe I deleted it here too. Maybe it wasn't here. Where did I get that? Oh, you know where that must have came from was in the register SPI, which is what I started from. Maybe that one was actually using it. I'm not sure. But now it's not being used, and having it do that would actually be bad because it would break the multi-byte address, because we'd clobber the byte at index 1, randomly set it to that. For the signed stuff, we just need, actually do want this one. Basically just need to do whatever this does when it gets the value. Have a signed bit now. That gets used down here. It's already there. Extract integer. So this is basically this. And then the signed thing right here for the 2's complement comes right after that. Drop that in there. It is calling this result instead of register. So result, or we return result. And then we do need to store signed bit. I copied that. I guess I never pasted it. Also, I thought I deleted this. I'm in the repo now. That's the downside of having the repo open and the device. So yeah, I was just editing code in the repo. I thought I was editing on my device, but I was actually in the repo. We do this a little bit. 30 there. That one is already there. We'll copy what and then what we'll do is I'll copy all the way back from my device into the repo. Everything. We might as well get this comment. I changed the name of this, but I didn't change the import or the constructor. Give shift count. 7. And I will say the unfortunate part about this is code came from Cloud. Not sure if it's correct because I don't know of a multi-byte. Well, this is not multi-byte though, I guess. Well, it is kinda though because of this. Also, it looks like this doesn't. Why do I think this? Oh yeah. Okay, I think that does make sense. Basically, there's register accessor generic, which really only just has this one function, whose purpose is to put the address into the buffer. You know, if it's a 1-byte address, then it's going to put the address in the first byte. You know, byte index 0. It's a multi-byte address, then it's going to put however many bytes of the address into that many of the first bytes of the buffer. But this part is doing wrong. So negative shift, I think, means that this is coming out negative. To make that hex. Actually, this whole thing will be, and actually I don't know the order of operation. Oh, okay, so there's parentheses. Actually, never mind. Yeah, parentheses. So we need to do all of this. That's going to tell us what we're shifting with this, and then that would be on the outside of all of it. So let's just say computed. Drop this here, and I'm assuming what we see is oh, interesting. Oh, okay. So this, I thought that I took. Couldn't have taken it from here because one only did one. In the, do that in hex, and then let's also get another one for final that's going to be this whole thing. Yeah, we totally did come up with a -8. I mean, so we're trying to put the address into it. Should this matter? I think this. So for a single byte address, this should not matter because least significant byte first really is only indicating the order of the bytes, not the order of the bits. So if we only have 1 byte, then there is no order. It just is the only one. So in the case of a 1 byte address, which is what we have, the logic should work the same. We should end up putting the exact same address. Which means I think this has to be wrong. Not super surprising, because like I said, this did actually just come from Cloud. I was not sure about it. Hmm. Yeah, these are all wrong. Think for a second here. So, I mean, an easy solution would be something like if we just said or if that's 1, then don't worry about significant byte first. Called it the wrong thing. Called it the wrong thing. Bunch of time. So that actually works. So yeah, this code is wrong. This is wrong. And bad part about it is I didn't write it. I took it from the old chatbot. And if I'm honest, I don't understand. But the difference is I in range. Could we just go backwards? But that doesn't really work, does it? And I don't have all those printouts. Well, but also the equation is essentially we need to get the bytes out of the address. The address comes in as an int. So it could be up to however many bytes an int in Python is. However many that is. I think it's 4, because I think it's 32 bits for CircuitPython. Could be wrong still. We need to get those in reverse order and then put them into the address slots. Is what this code is attempting to do correctly. off the loop for now. Just do the setup only. Final is not in hex. Doesn't be all the same. I wonder, you know what we could do is just convert the integer? Can I do that? On convert to we could address 2 bytes, byte length. So that's gonna take our number, turn it into 4 bytes. Big Indian order. That's gonna leave me with bytes. Correct? That's also gonna leave me with int.from bytes, byte order. Do we want to do this? Because again, I don't think we want to do this because we still have the same fundamental thing, which is if the address width is 1, then nothing should change. And I don't want to have to keep this logic. This is like a kludge, I think. There should be math in here that makes it so that when address width is 1, you get the same number from this math as you would from this math. But when address width is more than 1, that's when this should be giving you different number. But if we convert this, well, okay, but it's I don't think this is gonna work because this is gonna change the address, but we really don't want that. How do we get it back? From bytes. Okay. Maybe. Well, no, these look wrong, but they didn't crash. Was 0 before? Those are wrong. Oh, but we're still doing this stuff. We should be not doing that anymore. So if we do this, then this should have the no longer different math. Now that should be. Oh, I need to. Still wrong. That is weird. Well, am I computed wrong? My computed is also wrong, actually. Not printing. So actually, okay, there. Oh, but I have no. Okay, so this is commented out. These are now correct. The computed is correct. The final is correct. Okay. So I will not be able to know if this actually works for multi-byte addresses until / unless I can find a device that has multi-byte addresses. If anyone happens to know of one, offhand, let me know. That will help in testing this. I guess we could try to use like. Is there a SPI target? I guess we could try to like make our own device. Be kind of hard, I guess. I don't know. I'm not sure. I'm not sure that's going to work. Let's explore this a little. So let's say if we had an address. Say we had an address like that. Occupies more than 1 byte. Because copy all for. I don't know. Does this go the byte order that the number is in? Or is it the byte order that you want the bytes to be in that you get back? But we can choose the number of bytes also. That doesn't tell me. I mean, I guess the input number is whatever the system is. So this must be the output number. Well, bytes in this case. I'm questioning, like, this might just be undoing itself, right? Like, we might just be converting it one way and then converting it right back with this. I'm not actually convinced that we are changing the order. We're just undoing it. That's the same number. 5451. We are getting close to time here, so if anyone's got questions, comments, interest, those of any devices that have addresses more than 1 byte in length, now's the time to get those in the chat. I will be back tomorrow over on my own stream. I think I'll keep working on this. One thing is that I got Logic Analyzer to work on this. But tomorrow we may spend a little bit of time on my stream trying to learn and figure out how to use the Logic Analyzer. But maybe a little bit more meta, depending on how long that takes us. Like, will then depend on how much time we get into actually coding. But I think that's where I would like to start tomorrow, is figure out how to use that thing. Because I suspect that it'll make all of this kind of debugging much. Okay, there we go. That's a different number. Now, the question is that correct or not? That part I don't know. So theoretically, this should just be swapped, right? We should just have A, B, and then FF. If everything like actually worked. Back to this though, I'm sure really which one we would put here. Okay, I called it 4 bytes of length, but I actually only have 2 bytes here. But it did swap them. All right, let me rerun it one more time with byte length 2 instead of 4. Pretty sure this is 8. In fact, I'll just hardcode that. When and where on Saturday? Yeah, good question. I am over on my own channel, which is on Twitch, FoamyGuy_Twitch. Somebody else beat me to the Foamy Guy name over there. And on YouTube, it is my YouTube channel is actually Zob like Rob Zombie, but the R and the Z are swapped, and actually might be EE at the end instead of IE. But the short answer is in this chat, in the same Discord that you're in right now, David, live broadcast chat on the Adafruit Discord, I drop links in there when I'm starting. So if you just watch that live broadcast chat, 10 a.m. Central Time tomorrow, Central U.S. Time, 10 a.m., I will drop the links in there to Twitch and YouTube when I'm getting started. And then from there, if you're interested in continuing to watch along week after week, you can subscribe, and that makes it easy to get to as well. Yeah, okay. All right, we can't go. I wish I could go back through my old run history of REPL, but that is definitely switched them. I did this, they would switch back, so shows us that we are still sort of the mercy of whatever we pass there. Ooh, I wish I could watch live for the logic analyzer setup. Yeah, it will be interesting. I have not used one before, but the quick start card makes it look pretty easy, so it will actually be. Okay, I think that's correct. So my understanding is, like, if you were actually using least significant byte, first equals false, the default is true, but if you were actually using false, like the SPA does, and you had a multi-byte address, then I think this is now... I think this is now correct. Although, actually, what does this do? I is not defined. So I would be... So I would be 0 the first time and 1 the second time. No, we're back to the wrong order. Yeah. We're back to the wrong order again. But when I printed it, we got the right order, but that's because I kind of was able to swap it here, it turns out. Yeah. Okay. Well, I've done this wrong somehow. But if I can get it to work like this, where we change the endianness first, and then we can just use the exact same math as this one, then we don't have to worry about trying to understand all of this. But I do need to get this part to actually swap correctly, that it's not doing. Where is it? So that looks correct, though, right? Okay. I don't know. Somehow this is undoing the order we're in, so I gotta look closer at that. Later. That I'm not quite sure about why that would be. I thought this was just taking 1 byte at a time out of the address and putting it into the buffer. But somehow it's still going in the wrong direction. So I have to figure that out. 10 a.m. 10 a.m. Central Time, U.S. Central. I don't know for sure if we're in daylight or standard right now, but Central U.S. time, 10 a.m. Central. So it's about it's about 5 p.m. right now. So 17 hours from now. Tomorrow morning, 17 hours from now, 10 a.m. Central. Okay, I will be back then. I will drop links in the Discord when I get started if anyone's interested in watching me figure out how to set up the logic analyzer and get back to playing with these to try to figure this out. The good news is, like, the actual SPI stuff is working. The phase, the polarity, those things which I hadn't messed with before, those are actually working, which is cool. I was worried that was going to get a little hairy, but it actually was not too bad at all. I now have a lot of extra prints in here, which are making it hard to see, although the temperature is coming out wrong. So let's not start. Turns out we're not quite ready to start celebrating just yet. We made it through the setup, but we are not getting the correct temperature. So I'll have to figure that part out as well. And then I still don't think the multi-byte address is actually correct, so mess with that. But that is it for tonight. Thank you everyone for watching. Hope you all have a good rest of your evening, good weekend. If you are not around for tomorrow's stream, then have a good weekend. Otherwise, that is it for now. Thanks again for watching. I should be back next week as well. So Friday the 3rd of October, we'll be back for Deep Dive at 5 p.m. Central, 4 p.m. No, I just said that wrong. 4 p.m. Central on Friday. 4 p.m. Central on Friday. It's 2 p.m. Pacific on Friday. It's 5 p.m. Eastern on Friday. Next week, October 3rd, I'll be back at that time. 4 p.m. Central, 5 p.m. Eastern, 2 p.m. Pacific. And then Saturday is 10 a.m. Central, and I usually just call it out in Central. The reason I use Eastern and Pacific for Deep Dive is Adafruit is in Eastern. Scott, who started the Deep Dive, is in Pacific, and so he usually billed it as 2 p.m. Pacific, 5 p.m. Eastern. So I keep those two, even though I'm over here in Central. Very confusing. But thank you, everyone. I will see you all later.